Okay, so today we're doing the metrics measurement lab, and as you can see right to the left of me over there, those are all the supplies you're going to be using to measure different things in the room. But before we get into that, we're going to do a quick review on just how to use the metric system and how to convert between measurements. But before we dive into that, I just wanted to give you guys kind of a brief history of the metric system and kind of why it's so useful compared to what we have in America and what's been used for most of history, which is the imperial system. So kind of if we go way back to even Roman times, they used something similar to the imperial system, but there was a couple problems with their system. One is their measurements were based off an inconsistent standard. And what I mean by that is, for example, the Romans' inch was based off their thumb, someone's thumb, probably someone important like the king. But as we all know, we all have different thumbs that are all different lengths, so there's no way to replicate that. And once that person, the king, may have died, then there's no way you can go back and recheck the thumb. And another example of that is the Roman mile was just basically, the Roman soldiers were trained to be, they were highly trained soldiers, so the Roman mile was just 1,000 double steps of Roman shoulders. And even though they might be pretty consistent, that's obviously not going to be replicable at all to how exact you want measurements to be. So again we have, and then another problem with the imperial system is that the units are kind of random. As you know, we have 1 inch is equal to, 1 foot is equal to 12 inches, and then 3 feet are equal to 1 yard. And there's just not consistency in how you convert across the units, which can make it really hard. Because I looked it up, apparently 1,760 yards are in a mile. It's always hard to keep that memorized, and it's just kind of a random number, so it's really easy to forget. But the metric system kind of fixes all those issues. So the first issue I'll talk about that it fixes it's non-random measurements. So basically in the metric system, I'm sure this is just review, but there's base units, which are going to be right here, and we have our base units: meter, which is the base unit for length, liter volume, gram is mass. And instead of just having a bunch of random different units like yard, feet, and inch, everything just scales up by a factor of 10 based on the prefix. So for example, if we added the prefix deca to meter, we would have decameter, and that would just be 10 times the length of a meter. So it's pretty easy to remember. And a hectometer would be 100 times the length of a regular meter. So just based off the prefix, you can tell. If you memorize these prefixes, you can really know what any unit means. And the second way the metric system fixes is better than the imperial system is because these standard units are based off nowadays kind of universal constants. And in 1791, the meter was defined as 1/10 millionths of the distance of the equator to the North Pole, which is something that's basically always going to be about the same. And so that's something that's replicable on someone's thumb. But scientists weren't satisfied with that being replicable enough, even though it's pretty consistent. So actually today, let me read this. A meter is defined by the time interval that light travels in a vacuum in 1/299,792,458 of a second. So basically, now the meter's defined by the speed of light, basically, that's something that is a universal constant and won't change. And even the kilogram recently has been changed to be defined by Planck's constant, which is a chemistry fact that looks at the amount of energy. the relationship between frequency and energy of a proton, which if you don't know what that means, that's okay, but it's just basically the point is our metric system's defined by universal truths that don't change. So it's very replicable and a good unit of measurement. So that's just kind of a mini history lesson. So now into actually how to use this. So I'm just gonna do one example with you guys and then I'll send you on your way. So for example, let's say I start with 40 meters and I want to get it into kilograms or kilometers, sorry. All I have to do is look at the prefix and from there I can figure out how to do it. So we have the unit here. So we know the meters are base units, are just going to be 1. And looking at the chart, every time you move on the chart, it increases or decreases by a factor of 10. So if we count 1, 2, 3, every time you move up, it's getting bigger or smaller by times 10. So times 10, 10 times 10 is 100, times 10 again, that's 1,000. So it's basically changing by times 1,000. And when we're going, meters is a smaller unit than kilometers, which means that our actual number is going to be getting smaller because 1,000 meters fit in 1 kilometer. So we're gonna have, if we're gonna have the same distance of something, we're gonna have less of it in kilometers. And again, we moved 3 times, so that's just gonna be 1,000. So all we have to do is divide by 1,000. And from there, so that will just be 0.04. And then you can also, if you guys have done this, you can just move the decimal. If you're dividing by 1,000, all you have to do is move the decimal 3 places to the left. So it would be 1, 2, 3. And so are there any questions on that? Or I'm sure you guys have done something like this before. So you can go ahead and there's a couple practice conversions on your sheet. I'll give you guys maybe like 3 or 4 minutes to do all those problems, and then we'll go over it, and then we'll get into the lab. So again, just do 1 through 5 on your sheet. And if you have any questions, just let me know. All right, okay, I think everyone finished. So, okay, so for the first one, I can go over that one. So we started out at 0.8 kilometers and it asked us to convert it to meters. So we go to our chart here and we can just kind of count one. So we're starting at kilometers, going to regular meters. That's going down 3 times. And then remember, each time's a factor of 10. So 10 times 10 times 10 times 10 3 times, because we moved 3 times, is going to be 1,000. So we know that we're changing by 1,000. And because we're starting at kilometers and getting the meters, that means we're going to be increasing how much actual our raw number, because there's more, 1,000 meters fit in 1 kilometer, so we have to increase our raw number. So all we do is 0.08 times 1,000, and that gets you 80 meters. Are there any questions on that? Okay. And yeah, definitely no shame if you have questions, but I have a volunteer for what did you put for number 2? 3. 3? Yep, that's correct, because we start at 0.3 centimeters and we're just moving down 1, which means it's just 1 factor of 10, because we're only moving 1. So and we're getting bigger because we're going from a bigger unit to a smaller unit, and then 0.3 times 10 is 3. And also, again, you can just move the decimal. Okay? All right, is everyone feeling good about this? I know we don't need to. I was kind of looking around and it looked like everyone was feeling good. So, all right, thanks for reviewing that. So now we're gonna go to the actual lab part of this. So, just to restate what I said earlier, yeah, you have all of your supplies over there, and you're gonna use those to find all these measurements. And one thing to note is the scale where you're gonna measure your weight is right over here. But other than that, everything will be over here. And also, we have 9 cups over here, which have each of your personal supplies that you'll need. So you can each grab a cup, and that should get you for most of the lab. Other note is we have some meter sticks on the wall, one right here, one over there, and they're each 1 meter off the ground, and then that's a meter stick. So the top of the meter stick will be 2 meters tall, and that should be enough to measure your height, because we all should be in that 1 meter to 2 meter range of height. And other than that, it's kind of up to you to figure out the best way how you want to measure these things. So just use your critical thinking and figure out how you want to do it. Okay. Okay. And then the other thing is, so one of them is you're going to do find the length and width of the room. And in order to do that, you're going to need to work in groups to figure that out. And also some other things, you might need people to help you out. So just whenever you get to those steps, you can make sure you pick a partner and do those steps together. All right.
Is it just a partner, or is it like groups of 3?
I would say for the width and the length, they could do groups of 3.
Yeah.
Because you're gonna have to hold those meter sticks in place as you move across the floors.
Yeah, but most of it's individual, but then so most of it's going to be individual. So it's kind of just, if you get to that step, you can find the people who are around where you are. And
Like
then do
if
it
you're trying to
together.
get your height, okay, and you go over here. I can put my hand here, this is perfect, but like I move my finger when I come off. Someone can help you figure that out, you know. But it's all your measurements, you're not sharing your weight with anybody else. Just me, and I'm not gonna say anything as I weigh more than everybody else. All right? Okay.
All right. So yeah, go ahead and get started.
That's what I was thinking. It's not feasible.
Gotta make sure you come over and get your cup of fries.
Okay, perfect.
Was it at 15?
Yeah, I just wanted